Traversable wormholes, stargates, and negative energy. Summary. Implementation of faster-than-light (FTL) interstellar travel via traversable wormholes generally requires engineering of spacetime into very specialized local geometries. The analysis of these via Einstein's general theory of relativity, plus the resultant equations of state, demonstrates that such geometries require the use of exotic matter. It has been claimed that since such matter violates the energy conditions, FTL spacetimes are not plausible. However, it has been shown that this is a spurious issue. The identification, magnitude, and production of exotic matter are seen to be a key technical challenge, however. These issues are reviewed and summarized, and an assessment on the present state of the resolution is provided. In 1985, Caltech physicists M. Morris and K. Thorne developed the principle of traversable wormholes based on Einstein's general theory of relativity, published in 1915. Morris and Thorne did this as an academic exercise at the request of Carl Sagan, who had completed the draft of his novel Contact. This little exercise led to the development of two new cottage industries in spacetime physics research: the study of traversable wormholes and the study of time machines. Wormholes are hyperspace tunnels through spacetime, connecting either remote regions within our universe or two different universes. They even connect different dimensions and different times. Space travelers would enter one side of the tunnel and exit the other, passing through the throat along the way. The travelers would move at less than c. c is the speed of light, 3 times 10 in the power of 8 meters per second. Through the wormhole, and therefore not violate special relativity, but external observers would view the travelers as traversing multi-light-year distances through space at FTL speed. This figure illustrates this effect. A stargate is a special class of traversable wormhole solutions to Einstein's general relativistic field equation that possesses very simple physics and flat entry and exit openings. Traversable wormholes are unlike the well-known non-traversable Einstein-Rosen bridges or Schwarzschild wormholes that are formed from collapsed stellar matter, that is, black holes, or spherically symmetric vacuum regions. Black holes are collapsed stars that have all their mass concentrated at an infinitesimal point, where the induced gravitational field crushes all matter and spacetime. However, even Einstein-Rosen bridges can be made traversable by an infinitesimal tweaking of their spacetime metric. In the case of black holes, the singularity of collapsed matter, along with its crushing gravity field, totally blocks the way through the tunnel. A traversable wormhole does not have a singularity blocking the tunnel, or any crushing gravity field. Explorers would enter one side of the tunnel, travel through the throat, and exit the other side. Traversable wormholes also do not possess an event horizon, a region of high gravitational field strength separating the inside space surrounding the black hole's singularity from the outside universe. Once you go through a black hole's event horizon, you can never come back out because you will have to attain FTL speed to escape it. Not even light can escape from an event horizon. Traversable wormholes are creatures of classical general relativity theory, allowing for very comfortable travel through the cosmic neighborhood. But from the viewpoint of modern physics, the cosmic neighborhood can encompass other universes, other space dimensions, and other times beyond the four-dimensional spacetime realm. Mankind has certainly not discovered all of the universe's facets, and will need to continue to construct new experiments and technology in order to verify or not these undisclosed facets. Wormholes can possess normal or backward, in special cases, motion through time, and the normal or non-existent gravitational stresses on space travelers. And their entry-exit openings, or throats, are spherically shaped, flat, cubic-shaped, polyhedral-shaped, generic-shaped, and so forth. Why consider wormholes for travel through space, time, and other dimensions? All standard space propulsion engineering is based on Newton's three laws of motion, which is dependent on the expenditure of propellant to induce thrust-generating momentum transfer on a spacecraft. Many investigators have proposed interstellar propulsion schemes based on a variety of nuclear, fission, fusion, and pulsed rockets, electric, ion or plasma, rockets, matter-antimatter annihilation rockets, solar or laser sails, fusion or laser ramjets, interstellar ion scoops, beamed energy propulsion, sails, rockets, and ramjets, and so forth. Many of these modes either have been experimentally tested at one time or another in our recent history, or remained as a theoretical proposals. But all are based on Newtonian mechanics. The limiting speed of spaceflight, based on any of these modes, is the speed of light.